Hey, hi, hello, everybody. Good morning, good afternoon, good evening, whatever time you're watching the video. Hello. We are jumping in today to more common factors. We're continuing with factoring, continuing with this kind of new area of polynomials, and we're going to do more common factors. So similar to yesterday, building on those ideas to just some more complicated things. So let's get right to it. We're going to be on page 329, and let's go ahead and start there. Here we are on page 329, talking more about some common factors. And what we're going to look at today, it's got the little kind of preamble saying binomial common factors. Well, yeah, we're going to jump into that. I'm going to start by reviewing what we did yesterday and then lead into what we're going to do today, which is a bit of a leap. But if we get there with little steps, it's not too big of a deal. So factor the following: 3xy plus 2y. Well, if I look at that thing, okay, the common factor would be both terms have a y. So I could factor out the y. It's like I'm dividing out the y. The first term, I have the 3x left. It's like I took out the y, plus 2, because I took out the y in the second term, right? Whatever I have, I can divide out, or I can factor out, I can remove out. Okay, let's go on to a similar one, 3xy squared plus 2y squared. Well, the y squared is my common factor. Both of these terms have a y squared. It doesn't really matter what that common piece is. As long as it's in this term and this term, I can factor it out. So I'd factor out the y squared, and I get left with the 3x plus 2. Okay, good. Let's keep going. Okay, well, this one's a little bit funky. Okay, 3x smiley face plus 2 smiley face. Well, the only reason I threw that in there, the reason I want to do that is to emphasize it doesn't matter what the piece looks like. It doesn't matter what my common factor looks like. If it's involved in both terms, I can factor it out. I can say, okay, here's my smiley face times 3x plus 2. I factored out the smiley face. It doesn't matter what that thing is. If it's a piece in both terms, I can factor it out. So then, okay, I go to something like this: 3x y minus 1 plus 2y minus 1. Well, what I want to recognize is this is really the same as what we just did, except instead of a smiley face, now I have a binomial. Okay, but if I look at it, I have a y minus 1 in this big term, and I have a y minus 1 in this big term. So what I could say is that y minus 1, just like my smiley face was the common factor, that y minus 1 could be my common factor. Okay, times, well, what did I have left? I removed the y minus 1, and I have a 3x left. And then I removed, or I factored out the y minus 1, and I just have plus 2 left. And that is my factored version. Okay, so I could have a binomial as a common factor. That's not something I should be afraid of. Okay, last one, very similarly. Hey, it's all x's now. 3x, x minus 1, plus 2x minus 1. You have the same set of brackets. You have the same binomial. That is my common factor. I can remove that out. I can factor the x minus 1 out. That is in common. And then I'd have 3x left, and I'd have plus 2 left. I factored the other piece out. And there you go. So that's what we're going to do today. Okay, it pulls the ideas from yesterday, and then we're going to build on this, and we're going to factor out when I have maybe more complicated pieces. Okay, so now these are the questions that you actually have. So you followed along for those ones, and now let's actually do these together. I'll do one, and then I'll let you do the two ahead of me. Factor the following by removing the greatest common factor. Okay, well, I've got 4x times x plus 7 minus 3 times x plus 7. And what I notice is both terms. Here's my first term, here's my second term. Remember, terms are separated by addition or subtraction. Okay, both of them contain that x plus 7. That's my common factor. I can factor out or remove out or divide out the x plus 7. That comes out front. And then inside my bracket, I would have Well, the x plus 7 went away. I just have 4x. And again, in the second term, the x plus 7, I factored that out. I divided that out. That went away. And I just have the minus 3. There you go. That is the factored version when I have a binomial GCF. Okay, B and C, go ahead and do those ahead of me, and I'll follow along.
346 minutes later.
And we are back. I did B, so you got your answer for B. And I'm part of the way through C. I looked at that and I said, hey, there's 4a plus 1 and 4a plus 1. That's the common factor. That's the thing I'm going to remove. There it is. The first term, when I remove the 4a plus 1, I just get left with the 9a. Okay, 4a plus 1, well, this is where I'm not super sure. It's going to be plus something, but then I have to remember, factoring this out is like dividing by my GCF. So I have 4a plus 1 divided by 4a plus 1. Anything divided by itself is just 1. Or the other way I might want to look at it is this bracket technically has a coefficient. In mathematics, we're usually lazy and we don't write things that we don't have to. But I could have said you had 1 in front of that bracket, and you know that means the same thing as just having the bracket. So that's where the 1 comes from. And there's your answer for C. All right, let's move down. Okay, and here we are looking at example 2. We're only going to do A and B. We're going to skip C and D. So I'll look at the first one, 3y plus 2 and 5y plus 1, 3y plus 2 and 4y. Well, hey, both of those terms have that 3y plus 2. That's my GCF. Both contain that same binomial, that same bracket. So I can factor that out, 3y plus 2. And then on the inside, well, I don't have the 3y plus 2. I factored that out. From the first term, I have 5y plus 1. And plus, from the other one, okay, I'd have a 4y. And here's where it said simplest form. Well, that's because if I look at the brackets, the first one is simplified. 3y plus 2, that's a nice simple binomial. It's as simple as it can get. But the second bracket, I can simplify this polynomial. 5y plus 1 plus 4y. The y's are like terms. I can combine those to 9y plus 1. So sometimes with factoring, and especially as we learn more and more methods, there's going to be multiple times that I have to factor or multiple things that I have to look at. So I have to keep that in mind that I continue factoring until I'm all the way done. Okay, looking at B, and with that in mind, I'm going to factor this thing. And this is maybe a good time to remind you, the first thing we look to with factoring is the GCF. Bring out any GCF. We've been focusing on these binomials, right? And maybe if I look at B, I see a minus 6. But the first thing I'm going to look at is just the numbers. 3 and 9. I could factor out a 3. I could just factor out a number. And you'd get a minus 6 minus 3a minus 6. I factored out, okay, the GCF, the 3 and the 9 were both divisible by 3. So I factored that out. And then I can factor further. We're always going to factor until I'm at the very bottom and I cannot factor anymore. Because what I see is, hey, on the inside of these brackets, I could still factor out an a minus 6. So I'd have 3. And then on the inside there, I'd have a minus 6. I factored that out. Okay. And when I remove the a minus 6, I get an a minus 3. Okay. So I have 3 times a minus 6 times a minus 3. And before I write my final answer, I'm actually going to point out I kind of have some redundant information. I have 3 times this times this. Well, this extra set of brackets aren't needed. It's just 3 things multiplied together. And I know order doesn't matter with multiplication, so I could actually go ahead and remove those brackets. I wouldn't actually need them. Okay, 3 times a minus 6 times a minus 3. That is fully factored. There you go. Alrighty, let's move on, and we're going to launch into something a little bit different. Something that will be used later in the unit. It's a technique that's really, really valuable. So we're going to look at it now and we're going to learn it now. Okay, And it's called factoring by grouping. And it's the last thing we're going to look at today. So it says sometimes polynomials in 4 terms can be factored by removing the GCF, the greatest common factor. Absolutely. Okay. This method is called factoring by grouping, and it's going to be huge when we learn how to factor trinomials and other things. So it says factor the following by grouping. Well, before we do this, what I want to remind you, whenever we factor, whenever I have the chance to factor, I always first look for a GCF. So x squared plus 3x plus 6x plus 18, I do not have a GCF. None of those are divisible by the same thing. Factoring by grouping says, well, I couldn't do the GCF, so I better look to another method. Okay. And what it means by grouping is group the first 2 together and group the second 2 terms together. And I'm going to factor each of them. So just looking at your first group, x squared plus 3x, if I factored that, I could remove an x, and I'd be left with an x plus 3. Okay. Next, the second term, plus 6x plus 18, I could bring out a 6. Both of those are divisible by 6, and it would be positive, so I need to include plus 6. And if I factored out that 6, I'd be left with x plus 3. So that plus sign in the middle is crucial. So if it's positive, I need the plus sign. If it was negative, I'd need the subtraction sign. That's going to be crucial. Okay. And now if I look at what I have, well, this is exactly what we did the whole lesson. I've got the same binomial in both of these pieces. I could actually factor this whole thing now because it has a GCF of x plus 3. So I take that and I remove that chunk. I factor it out. The x plus 3 comes out front. I factored it out. Okay. And inside, I'd be left with, well, you crossed off the x plus 3, you just have an x. You crossed off the x plus 3, you have plus 6. X plus 6. And there you go. My 2 factors. One of the factors is x plus 3. One of the factors is x plus 6. Done. I did it. I factored the whole thing through. So factoring by grouping, it's going to come into our other styles of factoring. That's why we learn it. That's why we look at it. It's going to be huge. It's a huge, huge idea. Okay, I'll do one more and then I'll let you go ahead of me. X squared minus 2x plus 12x minus 3. First thing I look at is the GCF. There is no GCF, so I'm stuck. And I have to look at grouping. So I say I can't factor the whole thing, but maybe if I looked at the first 2 terms and the other 2 terms, I could factor them individually. For the first one, your GCF would be 2x. Both of those terms are divisible by 2x. You get 4x minus 1. Then I go to the second terms, 12x minus 3. Well, both of those would be divisible by positive 3. 12x and negative 3, those would be divisible by positive 3. So plus 3, and then I factored out, I get 4x minus 1. And I noticed something really nice because after I did the grouping, I have one bracket with 4x minus 1 and another bracket with 4x minus 1, meaning I have a binomial GCF. I can factor out the 4x minus 1, and it's going to leave me with something nicer on the inside. You got rid of the 4x minus 1, 2x plus 3. There you go. My 2 factors. One of them is 4x minus 1. One of them is 2x plus 3. There is my answer. And I am going to do C quickly ahead of you guys, and then you'll be able to do D, E, and F to finish it off. So 8a squared minus 4a minus 10a plus 5. The first thing I'm going to look at is there a common factor? Always, 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 always. No matter how many new methods we learn, always look for a common factor. Well, there isn't one, but I'm glad I looked. So now I'm going to separate by grouping, and I'm going to say, well, I could look at the first 2 terms, and I could look at the second 2 terms. Okay. First term, 8a squared minus 4a, I could factor out a 4a, and you'd be left with 2a minus 1. Second group, this one's a little bit trickier, and there's a reason I wanted to do this one before I let you go. It has a subtract, a negative 10a, And what I need to do is, if I'm factoring a binomial, I need to factor out a negative in the first term. Okay, so the first one that I looked at, 8a squared minus 4a, I don't care about this minus 4a. If it had been negative 8a squared, I'd have to factor out that negative. So within what you're looking at, if the first term is negative, I need to factor it out. So between 10 and 5, I have a common factor of 5, but I'm also going to divide by the negative. I'm going to factor out the negative, so subtract 5. Negative 10a divided by negative 5 is positive 2a, and 5 divided by negative 5 is negative 1. And now I have my bracket, now I factored, and it happens to have worked out. I noticed that the binomial I got in both pieces was the exact same, meaning it's now a GCF that I could factor out from the full thing. So really crucial to factor out that negative and write it as subtraction. But then once I have my GCF, I could say, okay, factor out the 10a minus 1, and you'd be left with 4a and minus 5. There you go. There is my factored polynomial, and we're good to go. Okay, now D, E, F are all yours. Go ahead and do them ahead of me.
A few moments later.
Okay, we are jumping into F. I've got D and E done for you, and we'll do F. Just quickly looking at D, when I'm factoring and I have nothing to factor out, like 2a and 3 has no common factor, I can always factor out a 1. So that's what I do here. And it was negative, so I have to factor out the negative as well. But whenever there's no common factor, I can always factor out the 1. You have 1 of that thing. Okay, we're going to jump into F. And this one is a tricky question, a little bit of a trick to it. Something that I wouldn't actually give you or ever expect you to be able to do on your own. It's just written in the wrong way. And what we're going to do is, as we use this technique in the future, is we'll set our questions up in a way that they're always in the proper order. So this one, the proper order that's actually going to allow me to factor by grouping, I need to move the xy squared up, the 6x up, and I need to put that 18y squared at the end. And I wouldn't expect you to know how to do that. I wouldn't expect you to do that. So this is a bit of a mean question, but we'll go through and we'll factor from here. Because now I can factor by grouping, and I have some good common factors. I can bring out a 5x, and I get x minus 3y squared. And in the second grouping, I need to factor out that negative, and I can also factor out a 6. So minus 6, factor out the negative 6, x minus 3y squared. And I have my common binomial now that I can factor out. X minus 3y squared and 5x minus 6. So sometimes they'll be given in the wrong order. But again, that's kind of a mean question. I wouldn't actually give you that. And when we use factor by grouping, we'll always set it up in the right way. And I'll kind of explain that more in future lessons. So that's it. That's factoring by grouping, a way to extend our factoring using a common factor. So here's your homework, page 331. 1, A, B, C, D, E. 2, just the odd ones. Question 3, I want you to do all of them. And 14. So there you have it. And let's get started on the homework. That is it for today, folks. A little bit of an extension on factoring as we learn to factor bigger and bigger things. And this is a big stepping stone to what we're going to factor tomorrow and what we're going to spend the majority of this unit factoring. So pretty crucial skills, and we're just building until we can factor pretty much anything. Do the homework, send me an email, submit questions in the Google form, set up a one-on-one appointment, all of that. And always a reminder, smash that like button, hit subscribe. I will see everybody tomorrow.